This is class on response spectrum load analysis in Staad Pro. In this video, we are going to cover the following topics. Converting the file created for static equivalent load analysis to response spectrum load analysis. Number 2, the base shear result given in response spectrum load analysis and adhering the minimum requirement to be adopted in this. Design result study and furnishing an adoptable common reinforcement in a continuous beam and in a full length of a column. Now we are going to see the initial and basic procedure for making a design under response spectrum load analysis. Now the file we are having is the previous file wherein we made the design under static equivalent load analysis. This file we are going to do further works for finding a result under response spectrum load analysis. Okay. In this, go to load. Here the load combinations, load case details. In this load case details, the load number 1, 2, 3, 4, 5, 6 are the loads we have fit. The loads noted above 7, that is denoted in C, in blue color, that is C, is called for combinations. These combinations now we don't need, so click it. In the computer keyboard, press delete. This will ask whether to delete. So delete every load combinations we created just now in the previous video. Okay, now we deleted all the load combinations we created in the equivalent load analysis. Now what we are going to do is, listen it now. Our work starts from load and definition table only. Now see, this is the original table. Click definition. In this, go to reference load definition. Click add. In that, we are going to create a mass load. This is called a mass. Select a mass. The reference load case 1, let the same symbol be there. If anyone wants, you may change the name also. Add. The new reference load has come here. So click this, add. Now what are the types of loads? That is self weight, member load, floor load, everything we are going to add. Self weight, we are selecting self weight. In the direction of X we are giving, no need of sign, so put it as 1. Add. See, one load, self weight with in the direction of X with one unit multiplication has formed in this load and definition table. Then next, click Y, the same thing here, add here, this thing has come. The same thing for Z direction, add. Close it. Next, reference load, add. Member load, go to member load means the weight of the ball. The weight of ball in all floors is 13.8 kilonewton per meter. This application is made in the direction of X direction. GX means global X direction. Add. The same thing in Y direction. Add. The same thing in Z direction. Add. So now we have created wall load in all floors. Next, parapet wall, that is 5.8 kilonewton per meter. This is also create in all the 3 directions. X, add. The same thing, Y direction, add. The same thing, Z direction, add. Okay, now we have created wall loads. Self weight completed. Next, we are going to floor load. Floor load means Self weight we have already calculated. The floor load means dead load in floor load will come only for the floor finish. The floor finish weight is 1.5 kilonewton per m square. This we are going to apply in x direction firstly. The range we have already created. This is 1.5 meter to 12.5 meter, means we are not taking the roof. The pressure or floor finish weight is different, so excepting the roof slab we have selected. This range, this is the range, y range only we can feed. The x range and y z range we are not feeding, so if it is not fed, then the computer will take the entire building. Add, see here this add has come. The same thing in the direction of y, add. The same thing in the direction of z, add. Next, the floor finish, the roof finish, that will be 2.0. That is also in x direction. The range is 12.5 meter height to 15.5 meter height. Add. The same thing y direction, add. The same thing in z direction, add. Okay, the floor weights we have included. Next, the live load is also to be included here. This is residential building, so the live load is 2.5. The live load for the residential building is 2.5 kilonewton per m square. But in response spectrum analysis for earthquake related subjects, we can take the load as 25% of the load. This is less than 3 kilonewton, so 25% of the load is enough to consider in this. This is 2.5 kilonewton into 25%. Yes, this is the result. 0.625 is the load we are required to take as per the code. The two for floor slab only, excepting roof slab, 0.625. Okay, add a load of 0.625 kilonewton in the direction of x for ground floor to last but one floor, that is 12.5. Add the same thing in y direction, add in z direction, add. For roof slab, we are not required to add any live load for roof slab because the code itself recommends not to take the live load in the roof slab. So the load creation under reference load is over. Okay. Now these loads are to be assigned. Self weight, select the self weight, assign to entire view. Click this, assign, assigned. Same thing. Oh, this minus sign has already so this minus sign is not required, so you go to edit, remove this minus sign, so you put it as plus, change, close, select that, assign to view, assign. Next is the direction, that is also with the minus sign, so edit 1 plus 1, change, close, select the desired direction, assign to view, assign, complete. Okay, now the self weight we have assigned in all the directions. Next, weight of wall in all floor slabs excepting roof slab. What is, select this load, go to view, go to front view, select the beams up to last but one floor, select objects only, go to isometric, click outer. Now select beams parallel to x, beams parallel to z. So here assign to selected beams, assign. Okay, the same load, the same selected beams, change the load into y direction, assign to selected beam, yes. Again the same load in z direction selected. The same beams have already got selected in the sketch direction area, so assign to beam, yes. Okay. Next 5.8, the parapet wall weight. Parapet wall weight. For that, you go to view, normal view, go to front view, select the roof beam only, view that only, go to isometric. Now you will select the 5.8 kilonewton per meter. Now you have to select the, use the cursor to assign one outer beam only, click it, click the control in keypad and click that beam, outer beam only, holding the control key pressed, you select all the outer walls. Okay, all the outer walls got selected. Assign to the selected beam, click it, assign, yes. The load, parapet wall load as x direction load has got merged, that has got assigned. So with this, select y direction load, the same beams have already got selected, assign to the selected beam, yes, yes. Select z direction, assign to the selected beam, assign, yes. See, the parapet wall height, parapet wall weight and the part in floor level wall weights we have assigned. Next, click outside, go to view and normal view, whole slab view. Then floor weight, this is 1.5 kilonewton per meter square. See here, I have clicked the edit box. This is see here, this is 1.5 kilonewton per meter square. Okay, close it. This is now we are going to give this loading to all the floors. So these things have already been assigned because we have already taken this load from range to range. So all the floor loads we have already assigned. During creating the load itself, this got assigned. Okay. Now next, go to load case details. Now we are required to create another load. That load case, add. The load starts from number 7 because up to 6 we have already added. See here, 1, 2, 3, 4, 5, 6. Now next number is 7. This load is not mass load. This is seismic load. This is seismic load. We change the name into RS space X. RS means response spectrum in X direction. Add. This load has come here. Next, the same seismic load, number 8. This is next RS Y. Add RS space Z. Add. See here, we have created 3 response spectrum loads. Click RS X, click it, add. This pop-up window come, load item. Here you select response spectrum load. If you select these things, this table will come. See here, response spectrum. Code, which code we are following? This code for this one is 1893, IS 1893 2016. You select it. Combination methods, SQC, CQC, select CQC. Soil classification, custom, medium soil, you select it. This table will change into this one. Now you select direction of loading in X direction. This value will be 0.024 for zone 3 only. This value is taken from the formula Z by 2 into I by R into SA by G. This formula is given in code book. Those things we shall see deep into in the next class. For the time being, you take this. Then dampness ratio is 0.5 for the selected zone. Zone 3 it is selected. So this will come like this only. Then okay, now add this error. I think some error is coming. We shall add newly. RS add response spectrum load 1893-2016 CQC medium soil X direction 0.024 add. See here, this got added here. Soil type 2 got added. Now again RSY add response spectrum 1893-2016 code CQC medium soil Y direction 0.024 add. Got added in RSY. Again click RSZ. RSZ add response spectrum custom 1893-2016 CQC medium soil Z value, this is also 0.024 add. That also got added. Okay, now we have completed the process of adding loads here. Okay, what we are going to do next? Load combination. Click analysis and design, select concrete. The IS456 has already got selected. Oh sorry, click load automatic load combination, click here, automatic load combination, click again. Select load combination code number, this is IS456 bar IS800. Yeah, on selecting itself, this Staad has already taken it as under table number 18. Next, the load combination starts from serial number 10. You click generate loads. See, all the load types have got selected. The Staad has created and as given in the right side box. We can add. See, the load and definition box, all the load combination has got created here. Now the load combination has come up to 55, serial number 55, here it is. Okay, we can close it. Okay, loads created, load combinations created, everything is over. Now go to analysis and design. Select concrete, this is already selected. Run analysis, save. Okay, we got selected, but there is a warning of 8 number of warnings are there. View output file, done. Output file has come here. We can see what are the warnings. Warning number 1, UBC, IBC, that is not required to worry about. Equivalent, these are suggestions. Equivalent static load preference preferably be performed for regular. We have already performed it. We are warning. FC means concrete value. We have already taken it as 20. Oh, warning. Reinforcement percentage exceeds the maximum limit. We double click it. See here. Warning, reinforcement percentage exceeds maximum limit. In column number 30, it says reinforcement percentage exceeds. If it says like that, the cross section size we have already provided is 300 mm by 450 mm. That size is not enough. The computer says this. Likewise, next reinforcement percentage. Warning, reinforcement percentage exceeds. This is beam number 34. We shall see everything and we shall increase the size of the components. There you found it. This column is with lesser size. So you have found it everything, and we are changing the size now. Go to view, go to front view, that is the columns in the middle portion, that is the excepting the all round beams, the central columns are with lesser size. So in the foundation area and in the ground floor area, you select those things only. Selected, see the selected beams only. Go to isometric view. So this column in below the ground floor in the foundation area and the column in the ground floor area are found to be with lesser size. So select those. 1 minute for that also. Go to front view. Go to this, select this only. Okay. So now, okay, let it be like this. Now we are going to load properties. The size of the beams we are going to increase, or creating new, define new rectangular column. This YD we have already proposed as 0.45, let it be the same. The width of the column we have already proposed is at 0.3. Now you take it as 0.38, means 1.25 feet width of the column. Now add it. See here, new column height size has come here, so that we are going to assign. So this drawing we are going to assign 1, 2, 3, 4 only. So pressing the control button, select the columns, middle columns in the upper floor, sorry, in the ground floor and in the foundation. Select only 4 columns in the foundation area and in the ground floor area. Those things are found to be with lesser size. Selected those things, deselected, assign the selected beam, assign to the selected beam. If you assign this, it is automatically removes the previous selection and the new selection gets assigned. Assign. Yes. You have made a change to the structure. As a result of this, post-processing result will no longer be available. Do you want to delete all the result files? Yes. Okay. Now view whole structure. Okay. Now the building is ready for analysis again. Go to analysis. Run analysis. Save new. Then we have changed it, so save it. Task saves. See, only 2 warnings which we said above. Those things are simple things, we need not worry. So go to view file. The file result has come up here, as we said already. We can concrete design, double click it, the concrete design. The concrete design comes up in this page. From this here, you can select the last to the last, and then we can copy it in a Word file. From there we can analyze it. But before that, we need to do one thing that we shall see now. The base shear, it is called base shear, should be more than 90% of the base shear obtained in equivalent load method. For that, you scroll in the vertical menu in the left side. Participation factor. You double click this participation factor. Your form will come up. Just keep it to the right side. The participation factor. This is the last. Participation factor. Double click it. This will come up. This mass participation factor in percentage. Base shear means it is a shear in the column only. If a Shear comes in a column, thus that direction will be horizontal either in x direction or in z direction. See here, this percentage of mass shear with respect to the equivalent load analysis in the x direction, it is 90.503. Okay, but in the direction of z direction, it is also 90 plus 90.157. It is good actually. If supposing this is not 90% or less than 90%, in that case you should do what? In that case you should click in the same analysis and design result. This will be in miscellaneous commands. You click that. There you will find one cutoff mode shape. Click that. Here the default is 6 times reiteration. The maximum number of mode shape is number 6. The computer has already taken it as a default. If that percentage be less than 90%, you change it as 7 or 8 or 9, whatever it is we can assign. Now it is only, so for example, if you say as 9 also, take it as okay. You have made a change to the structure. The process will no longer be available. Do you want to change it? Yes, you press it as okay. Now we have mode shape, we have fit it as 9. Again you are required to during that this run analysis command will not be available for a function. In that case you click this result and close it, then only this will become available for running. You click it, run again, save it, new savings. We have made it as 9 times. Okay, now go to outer file. Okay, we should click not response spectrum, we should click participation factor. Click it. So it has made the reiteration for 9 times. The base shear in x direction has come to 93%. In z direction it has come to 92%. It is more than 90%, then it is double okay. Now you can copy the result from concrete to till the design end and you can check a value. Before that, this is not this. If you feel it is correct, you can check it. But it is another method. Go to post processing. This will ask all the load combinations. Apply OK. This is the sketch for displacement or deflection. Click beams. The drawing will appear along with bending moment diagram and etc. These are the right side tables are the parameters: maximum bending moment, maximum shear force, maximum axial force. Everything will be available for every beam. In all the load combinations are 55. Okay, those much. These are very cumbersome calculations. Now you come to the drawing. See here, previously we saw this click concrete. This here we are required to AS required in mm square is 4138 mm square. For this we need to use a 24 number of 16 mm diameter bar. It is a heavy column, so that's why this much of rod is required. So you can click the first floor, click concrete. This comes 3247 mm square. For this, number of rods are 12, each 20 mm diameter. So you can check this in every concrete design. This dimension is previous dimension is 300 mm by 450 mm. Here the area required is 2600 something. It's almost 50% of the rod required in ground floor. So you can click every portion and we can find which is best. Best means the maximum rod in the foundation level and the ground floor level. The size of the column is higher size, and above the size of the column is lesser size. So find a suitable reinforcement in foundation level and in ground floor level. Means the ground floor level is okay. This is the maximum rod, 4138 square mm. you are not required to provide the 16 ohm itself. This total rod required is area of reinforcement is required is 4138. Even you can provide 20 ohm rod or 25 ohm rod, whatever you want. This much. This is a very huge number of rods. Place the rods equally in all the faces. Close it. Likewise, you can see every place. This column rod here. This column size is 300 by 450. Required rod is only 12 mm rod of 12 numbers only. Same thing if you come to roof level. See here, this is 1375 square mm. So you select the columns and suggest a maximum reinforcement in the ground floor area that will continue to the last end. Okay. In respect of beams, you go to view, front view, plinth, you select only plinth beam, view that only, isometric view, you select one beam. This beam will be with higher reinforcement. See this needs 3 number of 12 mm diameter in the bottom, 6 number of 12 mm in the top. Here this is 7 number of 12 mm diameter in the top. Here the 12 mm is not most required. The area of reinforcement you calculate. The 12 mm itself is not the most required thing. You calculate the area of reinforcement and suggest your own idea using 16 ohm rod or whatever you feel it better. So for this beam, it comes next beam. The 7 number 12 mm rod comes up in the upper floor. Bottom it reduces. Next, see here it is also 12 mm. Sorry, 12 mm 7 numbers coming in the upper side. So 12 mm 7 numbers in the top. In the bottom it comes lesser. But not required to be provided the same thing. You can provide, if you are required to provide 2 layers, then you can change the reinforcement percentage in the midspan. But in general, midspan reinforcement may also be required to be equal to the reinforcement in the upper side. That is better for the safety of the building. Likewise, you can select every beam and suggest a common reinforcement for a total beam. Thank you. With this, we are completing the reinforcement, arriving the reinforcement for the beams and column. Thank you.